Hello everyone, my name is Kevin Coco. I'm the Chief Technology Officer for Ardusat. Excited to have you viewing today. Today I'm going to talk a brief talk on the maker movement and then how that relates to Ardusat, our company here. Talk a little bit about the products and services and then not spend too much time on that so we can get into some live demos. Makerspaces. This is actually something that we're seeing, they're popping up all across the entire world. And what we're also seeing are these makerspaces are actually popping up in schools, which I think is a really great thing. We're seeing them in CTE areas. We're also seeing them in a lot of libraries and science departments. And I believe that this is where a lot of the innovative schools are really putting some of their resources, and I think it's a great thing. When we look at also just last week we had the big Maker Fair, the one in California, and if we look at this hockey stick of growth, there's really something happening here across the world. We have over 1,000 of these Maker Fairs are happening, and this year, 2015, it's projected that there's going to be over 1 million people attending these Maker Fairs. So becoming so popular that they even had one at the White House. So we can see President Obama interacting with a student experiment right here. So what's causing all of this, and what does this really mean? So one of my favorite authors, Chris Anderson, his latest book written about a year and a half ago, Makers. So his thesis for this book is that this subculture that's been happening is actually moving and it's really making a disruptive change. And he's saying that, and others, that this is the beginning of the next industrial revolution. So that's a big statement. And what does that really mean? So if we think of the disruption that we've had, it's now easier, lower cost to free, and on your desktop you have the ability to do designing, prototyping, scaling, and distribution. And so an example of that might be like for designing, you could design a 3D object with, say, Tinkercad, free software. You could take that object, 3D print it. If this works well went through prototyping that you've just done there on your desktop, you have the ability to take that model and send it to a Shapeways or to a 3D hub or move that into injection molding. Same type of process can happen with components and electronics. Have a single PCB board printed, prototype that, and then the big difference too is distribution. We have places like Kickstarter and Etsy where if you have a product, now you can reach the world with that market. So when we think of a makerspace, I think if I asked 5 people what a makerspace is, I would probably get some different answers, but probably a lot of similar answers too. I think people might say, yeah, makerspace, that's where you have like 3D printers, laser cutters, maybe textiles, woodworking, electronics, coding, and then probably some type of community aspect having to do with a makerspace. Definitely another part of makerspaces is you'll see Arduinos in there. So Arduinos it's a computer, and more specifically a microcontroller. And this allows you to hook up circuits so you can put inputs and outputs. And in our case, we really concentrate on sensors. So this is a part of our product offering. So the thing that makes Arduino really interesting is this is an open hardware platform here. So the schematics, everything you need in order to produce that board is open source. So if you create this really innovative product, you can take that, market it, and sell it with no restrictions. So if we look at this name, Arduino, it's very similar to Ardusat. And if we think of, okay, the first part of Ardusat is Arduino, and the second part maybe will be a clue to what we're looking at here. So this is one of my favorite pictures. When I look at this picture, I really think this is STEM. So think of the science, technology, engineering, and mathematics that it takes to make something happen like this. So what we're looking at here is the International Space Station, and the Kibo arm is out of the International Space Station, and it has what is called the Peapod launcher. And what's coming out of there, we have those 3 objects. Those are each satellites. So these are tiny satellites, CubeSats, according to the CubeSat standard. And the first two satellites popping out of there are Ardusat 1 and Ardusat X. So these are actually the first two crowdsourced satellites that would have ever made it up into space. And if you think of like the maker movement and disruption, it's amazing, right? We had 4 engineers got together, decided they wanted to make and launch their own satellites, and they did it. So that was how Ardusat started. Since then, those engineers decided they were really great at making satellites, launching satellites, but really didn't understand the education market that well. And so since then, they've spun off Ardusat, and now we're in this exclusive partnership relationship. The company now is called Spire, and Ardusat is 100% dedicated to STEM education. So a little bit more about these CubeSats. So I talked about them being small, 10 centimeter by 10 centimeter by 10 centimeter cube. Really small. They fly up in a low Earth orbit. And on each one of these CubeSats that are launched, so Spire has launched those 2 and another 2 to make 4 launches to date. And in 2015, they have 20 more launches scheduled. And the goal is to build this constellation of satellites up to over 100 satellites in orbit. And on each one of these satellites, they have a small payload of sensors that Ardusat works with them on for student experiments. So we'll be offering these student experiment opportunities at the end of 2015. So what's causing all this disruption and rapid change that we're seeing? I feel that this really comes down to this exponential growth of computing over the last, really 110 years plus. I think many people have probably heard of Moore's Law, and this is that, on average, every 2 years, computing power doubles. And so this is exponential growth. And I think what we're doing is we're seeing the implications of this. So if we think of right in our pocket, the power we have in a cell phone, components getting smaller and cheaper, processing power getting increasing. And a lot of that technology is extending into these satellites and making it possible to do really amazing things with these small form factor satellites. So kind of one example is the next 20 satellites that are going out in that constellation by Spire. They're about the size of a loaf of bread. They're 3U satellites. They have 1,600 times the processing power as a space shuttle in the size of a loaf of bread. And so with this rapid change, I think it's now as important as ever to really get students prepared for this rapid growth. So moving into Ardusat and one of our products here. So the DemoSat. So this is a demonstration satellite. It is the exact 1-to-1 scale model of a 1U CubeSat. 3D printed frame, and you can see right at the core right there, that blue little board, you can see the Arduino Uno there. So that's the processor in there. On the top, you can see a representation that has like all of our sensors on there, battery powered and whatnot. And we'll look in a little bit detail as we look at our Ardusat Space Kit. So top left-hand corner, again, we have the Arduino, the real popular microcontroller. Millions of them have been sold across the world. And we have the kind of the common components that you have where you have a breadboard and jumper wires where you can then hook up these sensors that you see below. That middle line there of sensors, we have our light sensors. So we're looking at this spectrum where we can look at infrared light, so we can detect an object's temperature. We have luminosity, so this is that spectrum that our eyes can see. And then we have ultraviolet light, which has those damaging rays that we can actually do scientific measurements on. Bottom left-hand corner, we have the blue sensor there is our IMU, Inertial Measurement Unit. So this has all kinds of fun things going on. So we have an accelerometer, which is an X, Y, and Z, and we also have X, Y, and Z for the gyroscope and the magnetometer, and it also has a barometer on there. And then we have a temperature sensor. So if we think of these, we can hook up these sensors to our Arduino and really turn it into just a scientific tool. And from there, we can run a myriad of experiments. So it's kind of an exciting time right here at Ardusat. We've had our experiment platform for a while. The web version is still there, but we now have the experiment platform is now available in the Chrome Web Store. So if you just go to Chrome Web Store and you search for Ardusat, you will see our experiment platform there. You can quickly download it and run it on your laptop or Chromebook. Very exciting. So when we look at it, this you have the ability to hook up your Arduino and your Space Kit into this platform, and this is where you can see live data readings from all of these sensors. You have the ability to have different views on here. We have some really fun experiments have to do with like the drum kit, where you can turn sensors into senses, turn them into sounds, making really interactive. And then also you're streaming all this data. You have the ability to log this data. So you can select the sensors you want, the frequency, and then kick out a CSV file. And we really find that it's a really important time for us. So the data is everywhere, but really the hard part is really analyzing this data and finding value in data. And we see a lot of our students being tested across the country on this particular skill set. And when we're teaching these data science principles, I think it's always best if, rather than getting a random data set, is actually run an experiment and take that and generate your own data. And then from there, you can go into graphing and charting and working with spreadsheets and doing data science. And right now, we're looking here at the Ardusat Launch Pack. So this is really designed for the classroom. Our Ardusat Launch Pack comes with 7 of the Space Kits that we just saw, so Arduinos in the sensor suite. And really kind of the differences here is, sometimes you'll have maker products might be, maybe a little rough around the edges and can take a little bit of time to kind of get up and started. We really are surrounding this with technical support, professional development, learning resources that are just plug and play. Each one of those sensors, we have coding examples that you don't really need to know how to code at all. You can just plug in your sensors according to the wiring diagram, load this existing code, and then you get your live data. And then from there, once the students get started, really kind of where they can end up is kind of endless, which we really love. And then we have, obviously, we have that experiment platform, and when you purchase the launch pack, you get all of the feature sets that are available in the experiment platform. We have a warranty, and then we also have these mission packs. Like every 2 years, you'll get hardware and/or some type of experience that will deliver to the classroom. And right now, what I'd like to do, I'm going to go ahead and put up this video again. I'd like to introduce Ben. He's our Director of Learning, and he's going to go in and do some live demos for us.
All right. Thank you, Kevin. I am really happy to be here with you. I'm an educator and instructional designer by trade. Most of my career has been spent looking for the right technologies that help teachers. And I think that what we have here at Ardusat is something really special, because using technology for the sake of technology isn't good for anybody. But when you use the right technology at the right time, there's some magic that happens. And I'm excited to share some of that magic with you. All right, so right now, what we're looking at is our Learning Resources website. And we have some great stuff here. One of the questions that we get asked is, how long does it take me to adopt this? And my goal is to make this as easy and simple to adopt as possible. And I want this to be something that teachers and students can learn in less than an hour. So I'd encourage you to come here and check this out. I really want that little bit of excitement, of accomplishment, to be something that people feel right away when they start using the Space Kit. One of the first things people do, the hello world of Arduinos, is to get a light blinking. So if you look at the camera here, now we're seeing the basic circuit. It's just a couple of wires, a resistor, and an LED. And normally you can plug the Arduino into your computer using a USB port. I've got a little battery pack here that I just plug into this side to power. And now, ta-da, we have light. Woohoo! At my house, we get really excited about all these kinds of things. But it's so true that teachers love this. Students love this. There's something about getting a light to blink that's really exciting, and it's that little bit of a success that you can have early on when you're trying to adopt this type of technology. All right, let's get this out of the way. I want to show a few more things. All right, so the basic process for doing this is there's three main steps. First, you start with a wiring diagram, and we provide all those wiring diagrams. And then you need to load code onto the Arduino. That's usually done via a USB cord, a simple program called the Arduino IDE. And you can get code from anywhere. It's as simple as just opening up a file, just like Word or Excel. You open a file, and then you push the upload button, and it sends it to the Arduino. So once you've got the code there, then the excitement happens, and you are ready to start using the experiment platform. So I'm actually going to go through the process of installing the experiment platform. So here I am in the Chrome store, and all I have to do is do a search for Ardusat, and I'm going to click plus. I'll click add, and it'll take just a moment for it to add. All right, there we have it. Now I'm ready to go. I'm going to click on that, and it is going to launch. It'll take just a moment to prepare here. What I'm going to end up doing is going through and telling it which USB port I am going to use. You can log in with your account. A Gmail account is suggested. I'm going to continue without an account at the moment and start experimenting. And there's my connect button. Click on that, and I'll choose the port that I am using. Now click connect. So while that's loading up, I want you to look at the sensor. This is the IMU that Kevin mentioned earlier. There's 4 wires, and it's a pretty simple sensor. But now notice as I move this sensor around, how the data changes. Alright, I'm going to click over on the left, and I've got a list of all of the sensors, and I can see data for each of the different axes that are being registered as data points. Also notice, if I scroll down, I've got quite a few more that I can take a look at. Notice what happens when I move some of these other ones. Power there we go. Plug back in, and there's my data. So I think data and data analysis is one of those important skills that students of today are going to need for the jobs of tomorrow. I'm going to click up here on experiments, and I want to show you one of the experiments that we've used is a G-force experiment. So this is registering G-force, and one of the things we did recently is we went to our local amusement park, Lagoon, and we had participated in their high school physics day. So we used our wireless expansion kit and attached this sensor and the Arduino to students as they went on one of the rides. And it was really fun to be able to see a live representation of what they were experiencing. So as one student was on the ride, another student could see the G-forces that were actually generated by the ride. All right, I'm going to come back to all sensors view and show you one of the exciting things that the experiment platform can do, and that is data logging. So I'm going to click on data logging, and I'm just going to collect everything that this particular sensor can collect, and I'm going to keep it in a per seconds mode, but I could also do it in milliseconds, minutes, or hours. I'll give this a quick name. And I'll click start. All right, and then I can do my experiment, whatever I need to do to log that. And then I click stop. And look at that, your data is ready. Download the CSV. And when this is ready, downloaded, here I am looking at my data in Excel. So I can really dig in and have a lot of fun analyzing data. I can see giving students the opportunity to create their own data and then be able to organize and analyze what they were able to do with it. All right, so that is the experiment platform. If you have any questions, we have a lot of people here who are anxious and willing to help you out. On the left is Maureen Silva. She's our business development manager, and you can contact her through email. And of course, there's me and Kevin, and we're both anxious and willing to help you be successful. Thanks again for participating in our May webinar. Good luck.